Now that we know how to find asymptotes and holes and domain of a rational function, we're going to put all that together and graph it. We're also going to use the aid of a graphing calculator to help us finish our graph. The first step is we're going to find all of our asymptotes. As you recall from a previous video, what you need to do first is to factor everything. Well, the top part cannot be factored, but the bottom part could be factored as x plus 5 times x minus 3. I know I don't have any holes because I don't have any common factors, but let's go back to those vertical asymptotes. We set the denominator equal to 0 and solve for x. So here we have two vertical asymptotes, and we'll represent those as dashed or dotted lines. The next thing we want to do is we want to find any horizontal or oblique asymptotes. That's where we look at the degree of the numerator and the degree of the denominator. Well, if I were to distribute this 3 and write this as 3x squared plus 3 and look back over at the original function in the non-factored form, the degree of the numerator is 2 and the degree of the denominator is 2. And when those degrees are equal, the horizontal asymptote is y equals, because remember it is a horizontal line, the leading coefficient divided by the leading coefficient. So 3 over 1 or just 3. If you have a horizontal asymptote, you cannot have an oblique. So we're done with that. However, I want to see if the graph intersects this asymptote. So I want to set the function equal to the asymptote and solve for x. So we're going to take the function, which is 3x squared plus 3 over x squared plus 2x minus 15, and we're going to see, does it ever have a y value of 3? Because if it does, then it means that intersects the horizontal asymptote. So we're just going to cross multiply and solve for x. Which means it does cross the horizontal asymptote when x is 8 and of course y is 3. And I want to make sure I put that point on my graph. Right, so I have found the vertical asymptotes, I have found the horizontal asymptote, I have found if it intersects it. I know it doesn't have any holes because there's no common values. The next thing I want to do is I want to find any intercepts. How do you find the y-intercept? You're going to let x equal to 0. So in order to find, again, the y-intercept, you're going to let x equal to 0. So we have f of 0 equals 0 plus 3 over 0 plus 0 minus 15, which of course is negative 1/5. So when x is 0, y is negative 1/5. So it crosses the y-axis at that value. Then the harder one would be to find the x-intercept, and that's when you let f of x equal to 0, or in other words, you let y equal to 0. So we set the function equal to 0. Now earlier in the semester we talked a lot about when does a fraction equal to 0. The only time a fraction equals to 0 is when the numerator equals to 0. Again, you could cross multiply and verify that. So we're going to set the numerator equal to 0 and solve for x. I'm going to stop right there because if I take the square root, I get an imaginary number which doesn't exist on a real valued function, and so that tells me there are no x-intercepts. Right, so I have some vertical asymptotes, I have a horizontal asymptote, I have a y-intercept, and I know it crosses the horizontal asymptote at 8,3, and that's what I want to plot. So I have graphed on a graphing calculator my function. Now what does my paper need to look like? Well, we're going to draw in some things that we have found. We found that the vertical asymptotes at x equal to -5 and +3. So I want to graph those. And let's go ahead and label those on the graph. And then I want to graph the horizontal asymptote, and that was at y equals to 3. And then I know it crosses the horizontal asymptote at the point 8, 3. So let's see, 3, 4, 5, 6, 7, 8. So it crosses the horizontal asymptote there, and I know it had a y-intercept of 0, -1/5, which is about right there, and I know it does not cross the x-axis. So as I look over here, I'm going, we have this behavior. Well, I know I have an asymptote there. So I'm going to draw that in, but as it gets closer to the horizontal asymptote, I know it intersects, but it's going to stay really close to that asymptote. Here, it does like that between the two vertical asymptotes, but I know it's not going to touch the x-axis. It's going to come up and come back down. And then I have this part, and I know it's not going to cross the horizontal asymptote again. So yes, you can use your graphing calculator, but I also need to see the algebra. Let's go through the second example. So again, we're going to factor this. Aha! I have a common factor. So that tells me I'm going to have a whole. So I'm going to stop right here and go ahead and write that down. Whole is found with the common factor. So x is -5. And then remember, we need to evaluate or find the y value when x is -5 in the reduced function. So the whole I have found is when x is -5, y is +8/3. And I want to make sure that that goes on my graph. Alright, now that I have found my whole, let's go back to the vertical asymptote. That's the denominator that's left. So I have x plus 2 is equal to 0, so x is equal to -2. That's my vertical asymptote. Alright, so now I'm looking for horizontal or oblique, so I look at the degree of the numerator and the denominator. Those are the same, and so my horizontal asymptote is y equals to the leading coefficient divided by the leading coefficient. And I want to know, does the graph intersect this asymptote? How do I do that? I set the reduced function equal to that y value. So again, I'm just going to cross multiply, solve for x, and notice I don't get a value for x, so that tells me it does not cross that horizontal asymptote. So let's see, I've got a vertical asymptote, horizontal asymptote, I've got a holes, and now I need to find those intercepts. Alright, so to find the y-intercept, you let x equal to 0. Alright, so I have f of 0. I'm going to have 0 plus 0 minus 15. So that reduces to -3/2. So when x is 0, y is -3/2. And that's my y-intercept. The last thing I need to do is find the x-intercepts. I'm going to use my reduce function, just easier to work with, and I'm going to let that function equal to 0 and solve for x. And remember, you could cross multiply, or remember it's just the numerator. And so when x is 3, y is 0, and that's going to be my x-intercepts. So let's see, I have this point, which is an intercept. I have this point, which is an intercept. I have a hole here. I have vertical asymptote at x is equal to -2, and I have a horizontal asymptote at y is equal to 1. Now I need to put all that on a graph. So I did use my graphing calculator. I'm going to look at that. Now I'm going to put all my information on the graph. So x is equal to -2. Y is equal to 1. I have the point 0, -1.5, and the point 3, and I have a hole at -5 and a little more than 2. So that's the information I have from the algebra. Now I'm going to look at my picture and go, alright, we have this, it's going to get really close to this vertical asymptote, it's going to pass through those 2 points, and I know it does not cross my horizontal asymptote, so it's just going to get really close to it. Then here, same thing, it's going to get really close to that vertical asymptote, it's going to come down here, it's going to skip that one little dot, and keep getting closer to the horizontal asymptote without crossing it. And you notice that hole does not show up on this graphing calculator. You could zoom in, but again, you would have to know where to zoom in. Let's look at one last example. Again, we're going to start factoring it. That's the difference of 2 cubes. And this is the difference of 2 squares. And again, we have a common factor, so that tells me that there is a hole when x is 2. So I want to take my reduced equation, or reduced function, and plug in 2. 4, 8, 12 divided by 4 is 3. So when x is 2, y is 3, and that is definitely a hole on my graph. So now let's go back to the vertical asymptotes. The vertical asymptotes are found from the remaining denominator. So I have x equals -2. So I have found that, found the holes. Now I want to look here. Look at the degree of the numerator and the denominator, and again I'm going to look at my reduced function, and lo and behold, the numerator is higher than the denominator. So that means I'm going to have an oblique asymptote, which means I need to do long division. So again, x goes into x squared x times, subtract, everything goes away. That's pretty easy. So that's your remainder. Your oblique asymptote is y is equal to your quotient. Now let me explain that a little bit better. What I've actually done is I've rewritten this function. This is called an improper fraction. So we could change that to a mixed number. So this is the whole part, and this is the fractional part. And the whole part is that oblique asymptote. So does the function ever cross that oblique asymptote? So we're going to set the function equal to the asymptote, but this time the asymptote is x. So we're going to set x equal to, again, my reduced function, and see if it does indeed intersect. So I'm going to do that by cross multiplying. And lots of things cancel out, and I get 0 equals to 4, which is not possible, so no, it does not cross your oblique asymptote. So the next thing I need to find are the intercepts. So the y-intercept, I'm going to let x be 0, and again I'm going to use that reduced function, which is x squared plus 2x plus 4 over x plus 2. So I'm going to put in a 0 everywhere there is an x, and I believe I get 4 over 2, which is 2. And then my y-intercept I just found. Let's find the x-intercepts. I'm going to set the numerator equal to 0 and solve. Now, that does not factor. So how could you solve that if you don't factor? You'd have to use the quadratic formula. So let's see what happens. Notice that that is going to be a negative number underneath the square root, which is imaginary, which tells me there are no x-intercepts. So let's put together what we have. We have a vertical asymptote at x is equal to -2. We have a hole at 2, 3. We have an oblique asymptote at y equals to x, and we have a y-intercept at 0, 2. And we also know it doesn't cross the oblique asymptote, and we also know it doesn't cross the x-axis. So again, we're going to look at our graphing calculator. We're going to use our brain. Okay, so we have that vertical asymptote at -2 at x equals -2. Alright, so that's y equals mx plus b. So the y-intercept is 0, the slope is 1 over 1, so you have oblique means slanted. So you have that slanted line of y equals to x. We have a hole at 2, 3, and we have a y-intercept at 0, 2. Now that's not much, so we come over here. You could plot a lot more points. That's how we did it in the old days before a graphing calculator. We just let values of x be lots of numbers and plug them in and connect the dots. But now we have some technology that speeds it up. So look at this. So it's going to come really close to this asymptote, skip that little dot, and it looks like it comes on down a little bit and curves on up. But I know it doesn't cross the x-axis. And then here looks like it does something like that. So hopefully these are enough examples to show you how to find vertical asymptotes, horizontal asymptotes, oblique asymptotes, holes, and all of your intercepts, and if the graph crosses those oblique or horizontal asymptotes.